Hi, Mrs. B here. Let me help you with some of the harder problems with Chapter 5. You can use this any time in the chapter. I included a couple questions from each section, so you can forward it to whatever you're looking for. Okay, in 5.1, number 25, this is the type of problem like the bacteria problem that we did in class. It says, what is the download rate in megabytes per minute? So we would have megabytes in our numerator and minutes in our denominator. So for the megabytes, we have to find the change in megabytes from the start of that time to the end. So we would take 96 and subtract 24 to get that number. For the denominator, we have to find the change in time from 1 o'clock to 1:15. So that is 15 minutes. So in order to finish, we would just turn that into a unit rate and divide and find out how many megabytes that is per minute. On number 32, we have to find out per hour. So right now, we know that it's 25 square meters in 1/6 an hour. So I would multiply this by 6 over 6 to find out, well, how many square meters is that in an hour? This would get us for 1 hour. And then once we get that answer, let's multiply by 2 to find out how many megabytes it is in 2 hours. Okay, on the juice problem, this is a lot like the paint ratios that we did in class. So let's make a table. So what we know is that we need concentrate and water to make our juice. So we need a total column. So right now we know we need a 1/4 cup of concentrate for every 2 cups of water. So when we add those together, that's 2 1/4. And we're trying to make 18 cups total. So we have to, for our second row, we're going to need 18 as our total. So we have to find out how many groups of 2 1/4 there are in 18. So what you're going to want to do is take 18 and divide by 2 1/4 to figure out what you're going to multiply your recipe by. So we're going to be doing 18 over 1 divided by 9/4, which is multiplying by the reciprocal. So you're going to do this to get that magic number that we're going to multiply our recipe by in order to get the answer and fill in for the concentrate and the water. Okay, in 5.2, when we're deciding if things are proportional, one thing you can use that for is when triangles are similar shapes. So if we do a ratio of the bases and the height, so are the heights and the bases proportional? We're going to compare the heights and the bases of each of the triangles. So for our large triangle, we're trying to find out if 12 for the height and 15 for the base, is that proportional to our smaller triangle, where we have a height of 8 and a base of 10. So what you want to do is simplify those fractions and see if they're equivalent. Okay, this is the type of proportion that cross products are the way to go. So if I find the cross product and set them equal to each other, we can solve and find D. So for our first cross product, we have 5 times 4, which is 20. Let me change the color there. And then our second cross product, we have 2 times D minus 2. And we're going to set those equal to each other and solve the equation. So we have 2 times d minus 2 is equal to 20. So we're going to distribute. Remember to multiply each part by 2. So we have 2d minus 4 equals 20. And now we're going to add 4 to both sides. Now we have 2d equals 24. And then you're going to finish by dividing by 2. And then you want to plug that value in and see if that really works. Okay, in 5.5, we're finding slopes of lines. And we're also relating that to unit rates. So when you find the slope of the line, you want to make a little staircase going from one point to the next. And from that, we're going to find the rise and the run. So for the rise, we're seeing how much there's a change from y being 1.2 to 6. So we have to take 6 minus 1.2 to get the rise. For the run, we're finding out the change in x. So x goes from 4 for the bottom point to 10 for the upper point. So we're doing 10 minus 4. So this is a case where it's a little trickier because we end up with a decimal. So my suggestion, you can't leave an answer this way with a decimal and a fraction. So we want to get rid of that decimal. There's a couple ways you can do it. A kind of easy way is to multiply top and bottom by 10. And then once you get that answer, you want to simplify it. Okay? Because you want your answer to be in a whole number. Okay. Number 11, we're supposed to graph the data, then find and interpret the slope. So when you're graphing this, hopefully you're going to use graph paper because this is going to be a very sloppy graph for me. But remember that x goes on the x-axis, so that's our gallons. And then y is our miles, so that's on the y-axis. That's our dependent variable. And our gallons is counting by 5, so that would be super easy to do. And then our miles, really you shouldn't count by 162.5, you should count by a nice whole number, so I'm going to count by hundredths, because I have to go all the way up to 700. 200, 300, 400, 500. Oh dear, I'll make that smaller. Okay. That's kind of messy. But you get the idea that you have to find some sort of scale that's going to work for you. And I used hundredths. And then I'm going to plot my points. I'm not going to take my time to do that, but when I find the slope, what I'm going to do is take y. I'm going to use the point 0, 0, and I'm going to use the point 562.5. And when I find my change in y, we know that's going to be 162.5. And we're going to divide that by our change in x, which is 5. So we're going to end up with a slope of 32.5. And now when it says to interpret it, what that means is add the units to it. So our 162.5, that was miles, and our 5 was gallons. So what we did when we divided was we found miles per gallon. Okay, there's quite a few in 5.6 that I thought I would help you with, and The first section is to tell whether x and y show a direct variation when you're looking at an equation. We always want to get our equation to look like this. Y equals some number times x. So in order to do so, we have to get y by itself. So in each of these cases, that's really what we're doing, is we're putting y by itself. So for number 10, by adding x to both sides, we'll now be able to get rid of x on the left and just have y by itself. So we would end up with 4 plus x, or x plus 4. That is not a direct variation because we have that plus 4 in the way. That's keeping it from being proportional. So that's a no. For the second one, again, we want to get y by itself. So let's take away 3 from both sides. So now we're just going to be left with y equals x plus 3. Again, what's keeping it from being proportional is that plus 3. So that's another no. On number 4, let's get y by itself. So in this case, we could take away x, but then we're going to have negative y. So let's just add y to both sides. That's an easier way to get to what our goal. So now we're going to be able to cancel out negative y and positive y and have 0 there. So we just have x left. And on the right, we have y. So we have an equation that is directly proportional. And what is our k? Why, it's 1. When there's no number in front of x, that means it's a 1. So we found our constant multiplier to be 1 in that case. Okay, and our last one, in order to get y by itself, we have to divide by x. So we're left with this. 8 divided by x equals y. Okay, that does not follow the form of some number times x. That's 8 divided by x. So that's another no. Okay, on number 20, we're going to write an equation and find that constant. So that constant, because y equals kx, we can put in what we know. We know that y is 72 when x is 3. So we have k times 3 equals 72. So in order to solve this, we would just divide each side by 3. So we find out that k is 24. We're not done yet, though, because it says to write an equation that relates x and y. So all we know is that the relationship between x and y is that we have to multiply x by 24 in order to get to y. So our equation is that y is equal to 24 times x. We're just putting in that value of k into the form that any proportional relationship has. Okay, for our last one, so again, we know that y equals some number times x. And it's saying to prove, why does this line always pass through the origin? So what we could do is put in a 0 for y and put in a 0 for x and see if that's true. And we know that since when any number is multiplied by 0, we get 0. That's why that would be true. So our proof is just to put the 0 and the 0 into the equation. And we see that when x is 0, y must also be 0. One more. Okay, so for the concert ticket problem, we're telling whether it is a direct variation. We learned that any line that passes through the origin and is straight is a direct variation. Okay, so now we have to find k and write an equation. So when you're looking at a graph, k is the same as the slope of the line when it is a direct variation. So we have to find the slope of the line. A very easy pair of numbers to do this with would be 0, 0, and the first point, because we can get the rise of 26 when the run is 2. So our rise over our run would be 26 over 2. And now I'm going to go right ahead and label my units. My 26, that's dollars, and my 2 is tickets. So when we divide 26 divided by 2, we find out that it's $13 for a ticket. And they ask you, once you know that, you should be fine to find the cost of 14 tickets. 14 times 13, go ahead and figure that out to get the cost of all those tickets. Okay, so that ends your homework hint helps, and don't forget that you can also try the review video. Take care.